PFAS, an acronym for a family of chemicals known as per- and polyfluoroalkyl substances, are man-made compounds with widespread commercial use in surface coatings such as paints, polishes, fabric treatment, carpets, non-stick surface treatments, as well as surfactants historically found in foaming agents used in firefighting activities. PFAS chemicals such as perfluorooctane sulfanic acid, known as PFOS, and perfluorooctanoic acid, PFOA, have come under increased scrutiny by environmental regulatory agencies due to their toxicity, persistence in the environment, and increasing prevalence as contaminants in groundwater. Many PFAS compounds are extremely stable molecules, resistant to most in situ treatment methods. A breakthrough technology is now available that eliminates risk posed by PFAS contaminants in groundwater. The innovative solution allows for the treatment of PFAS in situ, removing the risk to human health and the environment, without the need for costly pumping. Hydrogeologist Rick McGregor, president of In Situ Remediation Services Limited in Canada, was contracted to perform an in situ remediation of groundwater contaminated with hydrocarbons and PFOS and PFOA, thought to be emanating from a nearby firefighting training area.
There's a bunch of factors with respect to PFAS and PFOA. One is that it's a new emerging contaminant, so not much is understood about the fate and transport of the contaminants themselves, which makes remediation, targeting, and designing programs a challenge. The second is once we do understand where it is, we have to get to very low detection limits, which is another challenge. The third challenge is actually, if we are doing in situ remediation, is actually trying to get the reagents to the contaminants themselves, which has always been a challenge for any contaminant.
PFAS contamination ends up being very, very large and dilute plumes, making it very difficult to ever treat the entire plume. And so what PlumeStop offers is a way to inject activated carbon in situ, create a barrier that's going to allow for containment of those plumes and prevention of those plumes from magnifying.
In the case of PlumeStop, we can actually inject the PlumeStop and get very good distribution. We know that from doing numerous cores at sites and looking at the actual distribution of the PlumeStop within the subsurface itself.
In an effort to better understand the longevity of the PFAS treatment at this particular site in Canada, Dr. Grant Carey, president of Pore Water Solutions and an expert in mathematical modelling and environmental forensics, became involved to model the site. Using the field data, Dr. Carey explored a number of conservative modelled scenarios calibrated to the site, which presumed ongoing secondary inputs of PFAS from infiltration, desorption and back diffusion from the aquifer matrix.
So after we inject PlumeStop, we've got a substantial reduction in groundwater concentrations because most of the mass moves into the activated carbon sorb phase. And that's a key step. If we're doing modeling, we've really got to make sure we do that step before we go further to evaluate the PlumeStop performance.
To date, the most effective method for treating PFAS-impacted groundwater has been to pump the groundwater out of the subsurface and filter it through activated carbon tanks.
The main benefit of PlumeStop over pump and treat is pump and treat, there's a lot of capital costs when you're setting up, and you've got long-term operation and maintenance. So every year you've got to make sure that system's working. And the nice thing about PlumeStop that we saw at Rick's site is that we had one injection event, and that was enough to sustain that source control for 100 years or more.
One of the big advantages of this issue is you target the actual area of contamination. So you're being a lot more effective with your remediation reagent as well as with how you're putting it in the ground.
So at Rick's site, we know for sure that it works with PFAS and PFOA. We saw multiple monitoring events after the injection of PlumeStop. We've seen non-detect PFAS and PFOA at every single monitoring well that we have at the site.
I've been personally working with REGENESIS probably 15, 16 years now. I've been fortunate to be involved in a lot of the first-time applications of the products in Canada. Overall, we've been very happy with the products and we find they're very great to work with.
Dr. Carey's work on modelling the efficacy of PlumeStop to treat PFAS was recently presented at the US National Groundwater Association Conference in Washington and the first International PFAS Conference in Melbourne, Australia. For more information on PlumeStop and how this breakthrough technology can eliminate the risks associated with PFAS, contact REGENESIS.